Most recently, about 3 weeks ago, we released Fortnite in early access. And Fortnite, in the first week, achieved 500,000 players and now is well over 1 million players. And it's also a tremendously fun game. Now, it's been in development at Epic for 5 or 6 years. And it's really a unique opportunity at a company like Epic to be able to work on a game that long. And we can only do it because we self-published the game and released it from Epic. But it's a really fun game. During the day, you can play with your friends and you collect resources to build bases. And then at night, these very stylized zombies come out and they try and take that base over, and you have to work with your friends cooperatively to defend it. But there's a lot of technology that we wanted to do that's very different than a game like Paragon. For instance, Fortnite is a full real-time environment. Because you can basically destroy everything in the world, there is no pre-computed lighting in that environment. All the lighting is dynamic, right? And that creates quite a challenge for a multiplayer type of a game. And we also wanted the characters to be very stylized and very cartoony. And we wanted the cinematics to be that way as well. So a little bit later on, I'll show you how we go about doing the storytelling, which was something that we helped build a tool to do the cinematic storytelling within Fortnite. So as I told you, in 2015, we allowed Unreal Engine to become free to developers to use. And Tim Sweeney himself just wanted everyone to be very clear that, he felt that we succeeded when other developers succeeded. And I just wanted to stress this because I think the message sometimes is not clear, that Epic is really quite an open company in that way. And Unreal Engine, if you've not taken the time to download it, is not the kind of tool set where you download a base tool set and then you constantly have to download, well, now I have to go get the material part of it, and now I have to go get the animation part of it. Now I want to do menus, and I have to go download the UI part of it, and I have to get the animation and all the different bits. When you download Unreal Engine, there's only one version of it. There's not a student version of it. There's not an indie version of it. It's one Unreal Engine. And if you go and download it today, it's the same version of Unreal that Activision downloads, the same version that Ubisoft downloads, the same version that Sony downloads. And all the features that I'm going to show you are available to everyone from the moment you open up the tool. So these are all the base features, the asset management, basically all the collaborative tools. But then it gets into the graphics rendering, the user interface. Sequencer is a brand new tool, has a version 4.12, but it's come out of experimentation. And it's basically a full nonlinear editing environment inside of Unreal Engine. And I'll show you how that works a little bit later. But you can basically do nonlinear editing, but without video clips. You can actually do live in-engine things and record action inside of Unreal Engine and play it back. So, for instance, the cinematic for Fortnite is actually action that's occurring in the game with live animation that's being brought in, and shots of it are stacked side by side in a linear timeline, and then you push play and it all plays back in real time at 30 plus frames a second. Composure is another brand new tool in it that allows you to composite full EXR frames with digital assets. So, if you think about a tool like Nuke that does that with purely back plates and sometimes with 3D objects in the front, we can now do that fully in real time, and I'll show you how that works as well. Those of you, anyone here in audio engineer or does audio work? So in the next couple of months, there's going to be a brand new audio engine that goes into Unreal that has all the physical properties of bouncing audio and occluding audio and ducking audio, not to mention the full ability to author audio and mix it in full, anything that you can sort of do in Wise and Fmod, and the ability to actually have an orchestra of people interactively generating audio and mixing it in real time. And there's some videos on YouTube of the programmer of this tool talking about its capabilities and showing it. And it's really quite remarkable. So you can go and look at all this stuff on our documentation site and see all these features. Anyone who's exploring, the other day we did one of these things, and a professor came and spoke to me from a university, I think in Brest. She was saying that we focus on artificial intelligence. So I think the engine, well, has a massive suite of artificial intelligence tools where you can have autonomous characters that you can interact with who have object avoidance and collision abilities in the engine with the environment query system. You can program behaviors into them. They know how to navigate all the environments. They know how to use the physics systems. So it's really a massive suite of tools, including the ability to create massive open landscape gameplay worlds. We did a demonstration, technical demonstration a couple years ago that was 100 square miles of photorealistic environment that you see in the lower left here, which was really quite stunning. They had artificial intelligent deer that would roam around, and as you ran through that environment, you could see them be disrupted. And that's one of the projects that we made available to the community. And as a matter of fact, you can go on YouTube and see that people have taken that project and they've actually inserted Mario in it. And you can see Mario running around scaring the deer. It's kind of interesting and kooky. Anyone see the videos of that? It's kind of interesting. I've started using Unreal so much for games, but not only for games, but for also all kinds of businesses, that it has become the fourth most used render by pretty much all industries. And I'm talking about the film industry, the automotive industry, the architecture industry. And a lot of that is because people are tired of waiting for the render to finish, right? For those of you who work in 3D and have to make pictures or make movies, and you push render and you're like, well, let's go get a coffee, and you get a coffee and you come back and you're like, well, do I need to get another coffee? Maybe I should have lunch. Maybe I need to do some push-ups. Maybe I need to run around the block. Maybe I need to do my laundry. What else can I do while you wait for your renders to finish? People are moving to real time because they don't need or want to wait for the render to finish. And that's, one of the reasons. The other reason is because interactivity goes a long way to creating an emotional connection with what you're looking at, right? And that emotional connection makes a big difference with anyone who has to make a decision. And there's lots of people that talk about that, and I have a couple videos that will show that in a few minutes. But in any case, there's lots of attention that is brought to the engine because of that, because of how many people in many different types of industries have switched to Unreal Engine, and it's won a lot of awards. But to go back to games, this last year at the electronics conference in Los Angeles, there were over 100 games that were shown on the floor of E3 done in Unreal Engine 4. And amazing games. And not all big, massive studio games, too. I don't know if you guys are familiar with some of these. Do you guys know about Abzu? It's a beautifully stylized game that was made by only 5 or 6 people. I don't think that studio is very big. And I think the Battleground game here is also done by a pretty Player Unknown. It's not a massive studio. It's a fairly small studio. And these guys generated this game and put it up on Steam, and I think in the first month or so they made $5 million, or they had 5 million downloads of this game. The numbers are staggering, how small teams are able to make games that compete with large studios. Absolver, State of Decay, Flame in the Flood. Some of my ex-colleagues made that game. I think that studio started with 4 people, and I don't think they're much larger now than maybe 6 or 7. Hellblade is another amazing game that shot to the top of the charts because of their digital humans and the different style of gaming that it was. Not to mention games like Kingdom of Hearts and old traditional classics like Tekken. And this is kind of across many different industries. We have offices in Japan and Korea, and Korean industry is really interesting for their ability to make 3D mobile games that look like what the Xbox 360 games look like, right? And the PS3 look like. And they're doing that stuff in Unreal Engine. It's really quite amazing. But in any case, Epic has grown a lot. It wasn't that long ago that there were not that many people. And this is from 2 years ago. And now probably everyone that works at Epic would not fit into that space. And primarily, one of the reasons that it's growing so much is because of the non-game business, right? There's a whole new division of Epic called the Enterprise Division. And the Enterprise Division is basically everything that is non-games. And I'm going to talk about that for a little while here for a couple of particular reasons. As I mentioned, we are contacted on a daily basis for developers. You know, do you know anyone who I can hire who knows Unreal Engine? And some of them are game companies, but a great many of them are companies like General Motors and Volkswagen and Audi and BMW and Mercedes and some of the largest architectural firms in the world, companies like Industrial Light and Magic and DreamWorks and Disney, primarily because they can create environments, they can create imagery, they can create experiences that create emotional connections to their products. And that makes an enormous difference in how they now do business. And so a lot of these companies still want to do architecture, they still want to do manufacturing, they still want to do media and entertainment, but they need a new type of developer, someone with a real-time skill set. And one of my jobs, and one of the reasons I travel around the world, is to help make sure that audiences and educators and schools and independent developers realize that there are a lot of people out there looking for talented developers who understand what the real-time skill set is. It is people who know how to generate content in real time, but also maybe know a lot about games, know how to engage people, know how to deliver an experience in a real-time environment. And it's really interesting. Let me show you a video from a company in Australia, because I think this is quite telling. And I may need to turn the sound up a little bit.
Disrupted by digital. And the most important thing is personalisation. People expect that these days. Being able to do mass personalisation on scale, that's the challenge. And it's simply impossible, even for our biggest dealers, to hold all of the stock. Tools like Showroom 360 allow us to approach the retail experience totally differently, to customise our vehicles not only to the car and the trim level, but then to add accessories and really personalise their car down to the order form.
Toyota has the most extensive range of vehicles in Australia. To be able to show the guest a vehicle that you're not carrying in stock gives us a distinct advantage over our competitors.
It's also allowed our salespeople to explain technologies previously almost impossible to explain in a normal 6-point cell. They can go down to explaining through CAD the engine technologies, the safety technologies, but also links the online experience to the in-store experience, which is a really big challenge for any retailer.
This is the best thing that's been introduced in the motor industry since I started back 42 years ago.
Every Toyota dealer now has a unit. In fact, many dealers are asking us for more.
We've seen an increase in sales, but we've also seen a dramatic increase in accessory sales.
Most impressive thing is the response by our guests, the consumers who are looking at the vehicle in a whole new way and engaging at a level that we've never been able to do, even on the web. There's a direct correlation in our early studies between those using Showroom 360 and the customer satisfaction. Watching the surprise and delight in somebody's eyes as they come in and personalise and build their own vehicle, it creates an emotional connection that previously was never available to us.
So that's really interesting. What you're looking at there is a large television in 270 Toyota dealerships, at least in Australia, and that started to propagate throughout North America, and I'm sure here in Europe. I don't know if you've seen them here. And And that's a big television with a computer attached to it running Unreal Engine. And every automobile that Toyota makes has been brought into the engine, and every accessory for every new product line for Toyota is able to be attached, right? So what's the challenge? The challenge is that they need an army of developers that can constantly bring that data from CAD into Unreal Engine and keep that up to date, right? Because they need to update that as frequently as they make new accessories, as frequently as they design new cars. So this is Toyota. Mercedes has one of these, BMW has one of these, and pretty soon, I don't know, I stopped looking at the lists, but the reality is that if you have to spend money on one of these things, are you going to make that decision based on looking at a piece of paper, a videotape, or do you not want to engage with it? Part of what you can see in this experience is what it looks like in the rain, what it looks like in the snow, what it looks like dirty, what it looks like clean, and you making the decision whether you want to spend 50,000, 60,000, 100,000 euros, €500,000 on a vehicle. You kind of want to know what you're investing in, right? What it looks like good, what it looks like bad. And so that's what you can do with that interactivity and engagement. And I think it's very interesting that you've got these people who don't know a thing about Unreal Engine, don't know a thing about what they're really talking about, but they know what they do. They sell a product through engagement. And it's really interesting to see. And that's really not the only part of it. So I was telling you about Composure, the tool inside of Unreal Engine. About a year ago, maybe a little bit more, we teamed up with General Motors and a studio in the UK, or in New York actually, called The Mill. They're in New York, Los Angeles, and the UK. And we created a promo for General Motors that featured digital automobiles in a real-time environment, but also this had to be done in real time. And it's called The Human Race, and I'll let you read what it says about it, and then I'll talk about it a little bit after, because this is a very different kind of story, and it features one of our first implementations of augmented reality in Unreal Engine. That's pretty cool, huh? So when we started working on this project, the majority of the technology for it didn't really exist. And this is actually the live project. And let me push play on it. And this is it running in simulation mode. And what I need to do is switch to the appropriate camera and hit G for game mode. There we go. Am I in the right game mode? Blah, blah, blah. Let me talk about it before we actually look at it. What we're looking at here is sequencer. And what you're looking at back here is full EXR plates. That's really, I don't remember the number of teraflops of data that the engine is actually pushing through, but those are live action plates being composited through composure into the scene. And this is actually the shots as they're cycling through. Now there's a camera. These are both digital cars. All that motion blur is coming in from Unreal Engine. All the shadows are coming in from Unreal Engine. And if I bear down into one of these shots, which I can do by double clicking on it, you see there's the top shot, here's the next shot. And now I'm actually looking at all the different layers of how this is assembled. So I've got the camera rig. This controls the camera and all the keyframes associated with it. Here's the focal length. Here's the aperture. Here's the exposure bias. And here's the transform of the camera, how the camera is moving in through space. Here are the two different cars. Here's the cine car. Here's the shadow pass of that second car because the shadow has to be composited additionally. Here's the actual animation. We can bear down and see how the animation, there can be multiple animations. We can have weighted animations that transition, and we see that quite a bit with characters. All the effects associated with an automobile. Additional camera rigs, additional animations. Here's all the different elements. I can look at some of the keyframes associated with some of the things by switching into keyframe mode. No keyframes on that. Let's see if there's any keyframes on any of these transforms. That's only a single keyframe. Nothing exciting there. There's a couple of keyframes. And then you've got the full ability to grab any of these keyframes and full interpolation modes like you would see in any type of editing tool. So a sequence like this is actually made up of kind of hundreds and hundreds of layers. You see all the layers of animation because you can burrow down into any different thing. Here's the sun and the sun direction that's giving all the reflections to the automobile. And what you saw in that sequence with that Cyclops cameras and the Raven, which is the car from the mill, is that that vehicle with all those tracking markers also has an array of cameras on top of it, which is called the Cyclops system. And that's a proprietary system from the mill. And what those cameras are doing is that they're capturing a real-time cube map in full HDR. And that cube map is creating every single frame a reflection sphere. And that reflection sphere is projected back onto the metallic surface of the automobile. And if we don't do this every single frame, if we don't do this at a really high resolution, it will not composite with that environment. It will not look real. And that's one of the technologies that was developed in order to pull this off and to make this achievable, is the ability, we've had the ability to have reflection maps inside of the engine, but we never had the ability to do a per frame update on a reflection map in full HDR with a 4K EXR plate streaming in at the same time. So now that all of this composites together with full shadow passes, and the other thing that we never had the ability to do prior to this project is have vehicles, let me burrow up here, that had bent normals. So one of the things about an automobile and about this type of rendering technology is that we've always had normal maps inside of game engines, but a metallic surface, and particularly an automotive surface, and one of the facts about the way that the auto industry renders vehicles, the glancing angle of a metallic surface has a very particular type of a normal map. It's called a bent normal. And so we had to generate that type of technology for the engine. Let me see if I can do this. There we go. So that's what I wanted to do. So now you're watching it play back in real time. I can go into the scene here and hit F11. I actually have 2 projects open, so it wouldn't surprise me if it hitches a little bit. Or crash altogether. Are you coming back? Let me look at the log. See if it's going to be okay. There we go. All right, so I'm being too ambitious trying to play 2 enormous projects at once on a laptop, but you can sort of see that. Let's try it one more time. I won't go full screen. One of the cool things that I can do, let me see if I can do it here. Nah, it's not going to do it. All right, never mind. I was being greedy and trying to play too much on a laptop at once. Even though it's got 32 gigs of RAM, you just only go so far. You will forgive me, yes? All right, back to PowerPoint. We can open this up later in the later session all by itself and play with it a little bit more. Because to show you how interactive it is, I've got some hotkeys that changes the colors of the car. It changes a lot of things, and you can see it all run in real time. I'm going to close it for now so that I don't distort the other project as well. All right. Let's move on in our presentation, and we can play with that a little bit later. Thank you. We already saw you. Okay. So when we made that project as well is when a lot of enthusiasm came about augmented reality. And, you know, in a sense, putting an automobile that does not exist on a road is very much augmented reality, you know, because you can do it with an automobile, you can do it with a lot of things, especially if it's photorealistic in a photorealistic environment and has full realistic reflections and shadows and all that stuff, and has motion blur and depth of field and all the cinematic elements. Apple saw a lot of that stuff, and they started coming and approaching us about some of the technology that they were working on. That any of you see the big release from Apple yesterday? Was it yesterday? The iPhone 8 or the iPhone 10, iPhone X? Well, no? Nobody saw that? Yes, you saw? So they just released a lot of information about the new iPhone X that has 30% more processing power and Metal 2. So when they saw a lot of the work that we were doing with the mill and augmented reality, they came to us and they said, well, we would like to do some stuff with you guys as well because we are developing this new hardware. And so they invited us to present at the Worldwide Developers Conference. And they sent some of this advanced hardware to Epic, and we started prototyping some new technology with Apple. One of them was ARKit, right? Before we got into ARKit, we also started working with Lucas because Unreal Engine has a VR editor built into the engine. Anyone working with VR aside from my friend? Yes. So virtual reality, you know, is very interesting and it's very fun. Now, there are many challenges in working with virtual reality, as those of you who develop with it know. But one of the interesting challenges about working in virtual reality is scale, right? How do you know when you throw someone into that environment that they will feel natural and normal and appropriately scaled in that environment, or the scale that you want them to feel? So in Unreal Engine, we have created a full VR editor that is not something you have to enable. It's fully enabled at all times, and all you have to do is push a button. And if you've got an Oculus or a Vive with controllers attached to it, you immediately launch into the VR editor. And at that point, you can have the full basic menus of Unreal available to you. So you have all the content tools, you've got all the tools to build lighting, bring lighting into the scene, rotate objects, scale objects. You can still teleport around the scene, or you can use other locomotion mechanics like dragging yourself around, scaling the scene, moving things around. And that's been in there now I think it started going in as an experimental feature in version 4.13, and it's matured and is now in version 4.16. It came out of experimental, and now in 4.17, it's been integrated into Apple software with the onset of Metal 2. So I'll show you another video. It just shows you how we did a little thing with them.
Sure, I can grab
and
onto the two
a
hands
little
and
known
seal
property
myself
called
up.
Star Wars.
I can also use this to rotate the world around me.
Oh, very cool.
I have a TIE fighter here too, so let's bring one of those in. Thanks to more than 5.5 teraflops of GPU performance, manipulating objects is super smooth and really intuitive.
Great. All right, can we have a squadron of those flying overhead?
Okay, what about from over there on the horizon to over there by the castle?
Great, perfect. Okay.
All right, let me teleport back down.
Oh, hey, seeing the castle back there reminds me we're missing one important element.
Right, how could I forget?
All right. Nice. Well, it looks really good silhouetted against the sky back there. Can we go in closer?
Sure thing. It's really cool how Metal 2 unlocks Unreal's advanced rendering feature set on the Mac.
Wow, yeah, really nice. All right, let's play this scene from here.
Okay.
Fun, huh? So if you are working in virtual reality, if you've got an Oculus or a Vive, give it a shot. It's where we've seen some practical applications of using it fairly extensively is those people doing architectural environments and really needing to understand what scale feels like in those architectural environments. They will probably do a rough layout with their content, and then they'll jump in and navigate that environment to make sure that it feels appropriately scaled to present to a client or whatever the case is. And then it's also kind of fun to goof off. One of the things you can do in that environment is if you are building a natural environment, you can actually spawn objects to fall with physics. So one of the other demonstrations that we have, you will see that you can spray things like rocks or garbage, and you can spray them and they will fall naturally into a place, and you can actually see if they feel natural, because as opposed to having to place things and make them look natural, you can actually use physics to place things. And you can do that by not looking in an isometric view and deciding if that feels right. You can do that by looking in a natural eye line and deciding if it feels right. A little known director by the name of Peter Jackson took notice of what we were doing. Anyone heard of that guy? Yeah. So he made a fairly insignificant set of movies called The Lord of the Rings and The Hobbit. I think maybe you've heard of him up here. But he spun off a whole separate company called Wingnut Entertainment. And they built a small prototype that they worked in conjunction with Apple to do. And they also presented this at the Worldwide Developers Conference. So in this demonstration, you could take an iPad Pro with a table like this. And what that iPad Pro does, and this is a piece of software from Apple called ARKit, which is available and fully integrated into Unreal Engine now. You basically will, the iPad Pro's cameras will track this table, for instance, and you will create your scene, highly optimized and profiled scene naturally, and you can use the iPad to have an interactive game that becomes projected through your iPad as an augmented reality game on the table, right? So this is one of the things that Apple is investing in heavily with their new technology and that they're talking about in their new iPhone and their new series yesterday or the day before when they announced that. So it's one thing to have, you know, Peter Jackson with the power of Weta to make this kind of thing, but there's been other companies too that very quickly were able to develop some fairly noteworthy prototypes within it. There's a company that actually caught the attention of Apple, and I think they had them on stage yesterday showing their new product, and I'll show you the video of that. So this is a group, I think they're called The game is called The Machine. And I think this is a really small development group. When I did the research on them, I think there's more information about them now. But when I looked into them, this was only a couple of guys making 2 games. And I think they're out of Shanghai, China. So this is not like some major development studio. This is guys who went and downloaded the developers' kits and started working on the game. And this is them showing you the filming through their capture on iPad. So I think this is important because it's one thing to have Weta do it, right? But it's another thing to have a couple guys in China. I believe this game is slated to release soon. Okay, so that's really cool stuff. Additionally, on the AR front, you also know that Google has spent a lot of time working in AR. They were some of the initial developers of the Tango technology. And Tango was actually coupled to a piece of hardware, right? They were creating a developer's kit, which was, sort of a crossbreed between a tablet and a phone. But recently, Google announced AR Core. And AR Core is the decoupling of the software from the hardware platform and making it available through basically the Android platform. So that's being integrated and will be in early access in the next version of Unreal Engine 4.18. And will be supported. And so I think that makes it really interesting to think about using things like ARKit, Sequencer, and Composure, and ARKit, and AR Core. For those of you interested in working and making games in AR, or making experiences, or anything for commercial clients of that nature. Now, another area that's been a really high area of focus for our CEO and for our company has been digital humans. And one of the reasons that this is such a big, important area, we've been pioneering a lot of these things with our Paragon characters, but Tim Sweeney really feels strongly about, because he feels strongly about what the future is going to be of AR and what the future is going to be of our interaction, right? And the idea of avatars is, I think, yet to find its maturity. But when you end up talking to someone digitally, and they are going to have digital representations of themselves and whatever it's going to be, whether it's VR or AR or however we're going to talk to somebody, the idea of talking to some cartoony representation of a character could be interesting if you choose it. But, also the idea of talking to someone in a photorealistic way in a digital environment is also very interesting. So we've spent a lot of time focusing on digital real-time characters, and there's been a lot of technology done on digital characters, but not in real time, right? The film industry has spent a lot of time perfecting digital doubles. But what you're about to see is something that we did at this last SIGGRAPH. And we did it with Mike Seymour. And for those of you who follow Mike's website, the VFX Guide, he spends a lot of time interviewing visual effects luminaries and talking about visual effects techniques and software of different kind. But one of the things about Mike is that he knows a lot of people, and he knows Paul Debevec. Anyone heard of Paul Debevec? Paul Debevec is a researcher in Southern California at University of USC. He's one of the original developers of temporal normal mapping and the big light field scanning systems, which is these huge arrays of cameras that are capable of capturing an image and creating a digital representation of a human with albedo and all the cavity mapping technology. So Mike Seymour had himself scanned, and for a while was one of the most photographed faces because the number of times your face is photographed in order to get all this data. He had tons and tons of data, from all these photographs that are taken to capture that infinite detail. So we paired up with him last year and a couple of companies to recreate him in virtual reality. And this past SIGGRAPH, he did 9 hours of interviews as a digital double. He was on one room with a full headset talking to a whole series of people as they were invited to be interviewed by him. And let me show you a little video that'll explain a little bit.
Hi, I'm Mike. Well, kind of virtual Mike, really. This is our Digital Human project, which is a collaboration of a whole lot of companies: Epic Games, 3Lateral, Cubic Motion, Tensun, the Wiki Human team, Sydney Uni, FX Guide, a whole bunch of people coming together to produce, well, a virtual human. And not only a virtual human, but one rendered in real time, puppeteered or driven in real time, rendered in real time, and not only that, but at 90 frames a second in stereo in VR.
So that's hard to do. That's really hard to do. Like I said, lots of people do digital doubles, but to make them, to capture that in real time, and here's some images. In the bottom of the light field scans, there's the output in the top of the albedo maps being applied to the digital scan, of the facial rig that had to be generated for his head, and of the actual mocap rig. It takes currently all those companies that you see in the top right, 3D Lateral, Cubic Motion, Tencent, who does a lot of work with digital humans, the Wiki Human project, which is kind of interesting group, and of course Unreal Engine to drive all that technology together and be able to represent it. It's great to take a look at this. Here's the link to it. There's a great article that he did on his site. And I encourage you to look at it. Later on today, if we have some time, we can open up this project and look at it as well. So, if that's not enough, one of the biggest groups that is working with Unreal Engine right now is the architectural visualization industry. Not just architectural visualization, but architecture, engineering, and construction, right? So there's lots of people that want to, once again, create an emotional connection to a space that does not exist. It's one thing to show you a picture of it. It's another thing to let you walk around in it, let you feel the space. There's been lots of people doing these types of environments and spaces in software like V-Ray and V-Red and Arnold and pieces of software like that. But it's the interactivity that I think is making a big difference for these companies. And what I'm showing you here is living rooms and bedrooms and office spaces. But, there's much more than that. There are enormous architecture firms that are making airports, that are making stadiums and, multi-billion-dollar environments that lots of people have to make decisions about. And trying to make decisions about those spaces is really, really challenging. Being able to show those places in a photorealistic way and let people walk around them, let people engage with them, goes a long way to that decision-making process. And being able to show that in a photorealistic way helps not have people be distracted by the medium, right? It's not about all photorealism. It's about not being distracted by the medium. The architecture industry cannot hire enough people to meet the demand of what they're looking for, and our phones ring off the hook. And I say that because if you are a student now, or if you're an educator training people in real-time skill set, it's just good to be aware because the game industry is growing, but it's not growing at the same pace. So it's just something to be aware of. Now I have an interesting little test for you all. Here are two images. One of them is a photograph and the other one's Unreal. And I just want to kind of let me know which is which. All right, so raise your hand if you think this is a photograph. Raise your hand if you think that's Unreal. Okay. Raise your hand if you think this is a photograph. Raise your hand if you think that's Unreal. Okay. You ready to see? How did you do? Yeah? Okay, good. Yeah, the way that actually this worked is that This was the architectural visualization, and then they built that. Yeah. So they actually did a good job of matching what they projected and predicted. And the goal, once again, isn't to capture that and say, oh, I'm trying to fake you to believe it. It's just to say, is that what you want? And somebody say, yes, build it for me. Okay, there it is, right? And so, as I mentioned, it's not just for these smaller spaces. I'm going to show you another video of a company in Montreal. The company's called Twinmotion, and Twinmotion sells a piece of software. Well, Twinmotion is a piece of software that is intended for the whole construction industry. So construction industry uses very specific software. They use Revit. And Revit is a really interesting piece of software because it does a lot more than just visualize. It is an architectural piece of software that calculates volumes and helps people understand how lighting can come into a space and how energy is used in spaces and so forth. It does a lot of things for the construction industry. But how do you transfer? There's way too much data coming out of Revit quite often for any visualization tool. So they function as an intermediary tool to get to the visualization side of it. And many people are coming to them because they want to preserve X amount of that data and then still be able to provide a service to customers. So here's something that they did with us this past summer. And process that could take months, if not years, to make a decision could be narrowed down if the right people are sitting in front of it going, yes, that's right. Think about what it takes to make a subway station or something like that, or it's a lot. So as I was telling you, that's construction, that's architecture, that's all these different groups. The media and entertainment business has also spent a tremendous amount of time focusing on how to get rid of that rendering lag. One of the largest groups in the media and entertainment group that is also, we get our share of calls from, is the pre-visualization community, right? And pre-visualization community has been using Unreal, some of them for quite some time, but many of them are still using pretty arcane tools. They're still doing pose-to-pose things in Maya and bringing them into After Effects or things like that, and handing a director still a small movie on an iPad, say, is this the shot you want, or is this how we're going to make your movie? But there are companies like The Third Floor and Halion that have integrated full Unreal Engine pipelines, and this is the kind of pre-visualizations they're making now. So that's just a small example. This is a much longer clip. Where this is likely to evolve to, with things that we've already done in the last couple of years, is to hand something like this to a director, and then to also hand him a camera and have that scene play back and give him a volume like this and say, well, how would you prefer the camera to be? And during playback, allow him to capture his own camera angles for a scene like that. And give him a motion capture actor and have the motion capture actor change the positioning of anyone. And then what many larger film companies are also trying to do is they're trying to go straight from this to render, right? Okay, great. If they're digital doubles, like in an Avatar type of film or something like that, can we switch these proxy assets to our high res and push render now, right? We currently don't presume that Unreal Engine is going to be used entirely for a film like an Avatar movie, because that render fidelity is still being rendered at something that proprietary renders are still doing things that we are not trying to do yet with shadows and reflections. It's become a ray traced world, and ray tracing is very expensive, right? We're not trying to propose that we are going to ray trace in that way. Those take hours and hours, 20 hours to render a motion blurred ray traced frame sometimes. But to be able to do this type of decision making and to push a button at some point and swap all your digital intermediaries into full res proxies and send it to the render, lets the director walk away and not have to come back for edit sometimes. He can come back and color correct or something like that, but he goes on to the next movie, right? He doesn't have to come back and go, now give me all the stuff, and go into CG post and sit for another 3 days and watch all that footage come back and decide how to edit it together. They're editing during pre-production if they can get past the digital intermediaries. And that's what they're doing in television. Okay, so this is a company by the name of Digital Dimensions. They are doing a show called Safari. Because they are able to animate in your typical content creation tools like Max and Meyer and do mocap and do whatever, they are able to, instead of doing all the pre-production work and animation work and then send it to a renderer and come back and edit it together, post-produce it, put together a 22-minute episode and send it to a network or whoever, they can basically assemble a shot, put it into sequencer, hit render, or output the frames, whatever they need to do, whatever the deliverable is, and double, triple the amount of episodes that they can do by eliminating the editing and the rendering pass. And so they're able to deliver 36 episodes to their whoever's airing the show, because they're eliminated the editing and the rendering process. And you're going to probably see a lot more of this type of thing. This is one of the first. If you type in Safari, you can read all about this. We've put a nice blog about this particular project and see some of the actual footage. It's pretty cool. So this leads me to what we did at Epic, because there's so much interest in this. Disney's interested in this. DreamWorks is interested in this. These big companies, Blue Sky's interested in this, that are making the movies that we are used to seeing. And they're interested in how quickly they can iterate on full digital production of animated movies. So when we were making Fortnite, we were given a task internally, a small team. I think it started with 4 guys, and it only grew to a couple of more. It didn't really take that many. It said, create a compelling cinematic version of our Fortnite world and characters that most viewers would have a hard time feeling that is in the engine. Let's make it look like something that would be done by Maya or something rendered by an animation company. But it has to run real time, 24 frames a second. And that goal was to submit it, one of the goals was to submit it to SIGGRAPH, which has an animation festival every summer. But the goal was not to submit it as a film, to submit it as a live short. In other words, they wanted to play it live in engine and not, hey, anyone can render frames. That's just going back to digital content creation. So it was done this summer. It played back at 41.67 milliseconds, which is really outstanding for the actual amount of content that was made. The production cycle was a very typical cycle. Went through a full storyboarding pass, brought into Unreal, set up entirely in Sequencer. All the lighting is fully interactive. Sequencer is really powerful because you can bring lights in there, and the lights exist per shot. They're spawned in a shot, and then when the shot is over, they're removed, and the memory is purged from that particular shot. All the animation is done and brought together in the shot. And basically, one of the real powers of something like that is that as you set up your cameras and you set up your lighting and all the dramatic elements that you're trying to achieve, if you're not satisfied, you can just change it instantly and push play, and it's done, right? You don't have to change it and re-render that sequence and reintegrate it through edit and all that stuff. You change it, push play, and you're done. Or you change it and save a different take of it, and you go back to any decision maker and say, do you like take A, B, C, D, or F, whatever. Choose one, and it's a non-destructive workflow. One of the other things that was really critical about Fortnite is that they really wanted to have a different type of facial animation. My background, as Cecilia was saying, was television as a technical artist in rigor, and then I went to film as a technical artist in rigor, and I worked on the movie Ice Age and Robots. And rigging a face for animation has always been a really interesting challenge, because when you rig a face, quite typically you put a massive network of joints. And what you're trying to approximate is radial motion, right? Because our faces move over bones, skin sliding over bones. Well, what do you get when you put a joint? What you get is linear motion, right? So one of the distinctions that I had as a technical artist in film is that the little squirrel in the movie Ice Age, did you all see that movie? I got to rig him for animation. Each one of his upper eyelids had 90 joints alone. Why? Because in order for them to roll over his eye, they had to all collapse. And that was just to create a radial motion over his eyelids that was not blend shape in a shape interpolation. It was joint-driven radial motion. So how do we do that? You can't have 90 joints on an eyelid in real time and still get radial motion. Well, you can do that through alembic caching. You can do that by having a different shape every frame. Yeah? If you imagine the kind of interest you would have if you made a zebra sculpt every frame of anything you wanted. That's what using alembic caching technology does in facial animation. And that's exactly what we did in Fortnite. Every single pose of a character is a different sculpt in essence. And now when you smile, instead of using joints in a linear fashion, you can have the full curl of the smile. You can have the full puff of the cheek, the full roundness of the eye, because it's not going from here to here. It actually can do whatever every shape does, right? So let me show you what that looks like. That pucker to open, you could never do that with joints, or it wouldn't look that way anyway. So the pipeline for these characters is full motion capture body, joint driven, full alembic cached heads. And since we did this, Disney has had to come and get trained on how to do that, and DreamWorks has had to come train and get to do that. You know, and all the major companies are like, how do you do it? It's still a real pain in the ass to do. Don't come asking how to do it, because we need to make a better process. Our user experience on it is awful. But it'll get better. That's the way we do it at Epic. We do it the hard way, and Celia says, no, that's no good. You have to do it better than that, and we figure out better ways to do it.
Et vous laisser la parole et que vous puissiez vous poser vos questions. Et puis Louis va s'adapter à ce que vous voulez savoir pour la deuxième partie. Alors, qui a des questions? Oui. Plus pour la présentation de Louis. C'était quoi ta question?
Je voudrais savoir si on peut créer vraiment un jeu à partir uniquement. I would like to know if it's. I heard many people saying that we can't do a game only with blueprints. I would like to know if it's possible to do so.
Sure. So, Blueprints is a virtual machine language. When I compile let's see here. I'm going to close this down and I'll open up another session. And we can look at some stuff here. So Blueprints is a virtual machine language that compiles to something that is only at about 8 to 10 times slower than single-threaded C++. Okay, so there are many ways to achieve performance in the engine. If you are writing multi-threaded C++, it is really, really, really fast. If you're just writing basic C++, it's still really fast. Blueprints is still quite fast. Okay, so if I open up a blueprint, and the minute I push this compile button, you know, this still is going to be really very fast. And there are many games that stay all blueprint. There are many games that are half blueprint and that are half C++. If you go and download Robo Recall, the mod, from the launcher, it's a shipped game that was made for virtual reality that had a frame rate target of 90 frames, you know, if not faster, 120 frames. You can go through it and you will see a lot of blueprint. You will see a lot of C++. The answer to your question is what are your frame rate goals? If your frame rate goals are achieved with blueprint and C++, you're fine. Yes, because what you need to look at is what your resources are as a team of developers. If you've got artists and designers and programmers, and your artists and designers can create gameplay code in Blueprint, and you're hitting your target frame rate, you're fine. If you only have one programmer and 6 designers and artists, and they can still generate gameplay code in Blueprint, and you're hitting 60 frames a second, 90 frames a second, whatever you need, you're fine. That's what Robo Recall is. If you look inside of Paragon, if you look inside of Fortnite, there's a lot of blueprint in there. Why? Because we don't care, right? It hits the frame rate we need and it's fine, right? Now, when you go to bake an asset, when you go to build a project, file, cook project, when you package it, you have the option to nativize your blueprints, right? And when you nativize your blueprints, that turns your blueprints into C++ code. So if you don't want blueprints to be in your project, you can turn all your blueprints into C++, and you're going to gain that performance boost. But you're not going to be able to read the C++ code that Unreal makes for you. So that's a one-way trip at the end of your project, because we're not trying to make it so that then you can edit your C++ afterwards. We're just trying to give you the speed performance. So that's called blueprint nativization. And there's a method, and you can read about it, you know, and there's documentation about blueprint nativization. And it was experimental for a number of sessions of the engine, and it's now a fully mature, but basically converts Blueprint into C++. But like I said, you do it once at the end of the project, and that's it, right? But like I said, also, you can look at all the projects that we make at Epic, and there's a ton of Blueprint code, and it's because it doesn't really matter. It works fine. We hit our frame rate, and you're good to go. Does that answer your question?
D'autres questions?
Can I use all other language like C++ to build a project like C# or Java or Swift?
So you cannot. Unreal Engine is a C++ engine. It's been a C++ engine really since the beginning, primarily because of its relationship to the console development. C++ is an old native language that talks to machines well, and that's one of the reasons because Unreal Engine's been talking to consoles really since the early development cycles. There are third-party companies that have been experimenting and exploring, integrating C# into Unreal Engine. It's not a priority for Epic because we don't particularly need it. The way we develop features for Unreal Engine internal to Epic is we look at projects like Paragon and Fortnite or some of the projects that I showed you, and we see what features might be valuable for those particular projects. And because we have a small army of C++ programmers, now, having said that, if you look at the industries that are asking us to work with them, one of the biggest industries is the visual effects industry. What is one of the most common languages used in the visual effects industry? Anybody? So what might you see sooner than later in Unreal Engine? Because it's a good tool pipeline language. And that would be more valuable than another C# language, which, it's just kind of the same thing. Well, it does the same thing, and that Blueprint does, and it does the same thing that C++ does in many ways. What Python does is gives you a framework for building tools inside of the engine, at least for the visual effects community. At least, I'm not telling you what I think, I'm telling you what the engineering community at Epic, the arguments that I have heard are. Now, that's not to say that you won't at some point be able to buy somebody's third-party plugin that gives you C# access. And I am aware of a number of companies that have talked about it or have released versions of it.
Other questions?
Hi. Just a question about the material editor. I know we work because I worked on UDK a long time ago, but in the Unreal Engine 4, the custom lighting disappear. It's, I think.
Matinee? Which tool disappeared?
The custom lighting in the material editor.
The material editor. What disappeared? What
the
about?
custom lighting option, so we can work directly on how the shadow work, or use some map to control the lighting, not the surface, but the lighting, or the lighting work with the surface. Well, just all the complicated feature of the CG language. And in Unreal Engine 4, I didn't see all of that. Or any way.
I'm sorry. I'm having just a little bit of a hard time understanding. No, it's my ear's not used to understanding. Do you know what he's asking? I'm sorry.
Well, with the CG language, we can work on with the shader and create some very complicated lighting function that work really different than the PBR one. And my question is, can we do the same with Unreal Engine or not? Can we rework the lighting algorithm of the shader to change how the surface reacts different than the PBR one?
Can you make your own materials?
Not really the material, the shader. The shader.
The shader, yeah.
Yes.
Can you make your own shaders?
Yes.
Yes.
And
Yes, as of version 4.17, you can make your own shaders.
with the material editor directly?
You can, so, let me see if I have internet access. There's just this morning, yesterday, one of our graphics programmers created a blog on our website that talks exactly about how to create your own shading code, because there's basically a folder with all the shading code. They're basically templates.
Okay.
And he shows you a bunch of example code about how you can generate your own shader code. You can do a couple things in the editor. You can actually use high-level shading language code in the editor, and there is examples of that, how to use high-level shading language. That's one way to do it, but you can also actually create your own UCF files, which are template files for shaders and materials. And so, like, there are other industries that are interested in this type of thing. And so if you go to the blogs, Roland, which is one of our developers, our graphics programmers, just wrote a blog yesterday or today about how to generate your own shaders and in Unreal Engine.
Okay, thanks.
Yeah.
That's cool.
Let me see. Let me see if I can find it.
While you look at it for it, juste pour vous rappeler, donc sur unrealengine.com, donc il y a toute la documentation par sujet, mais on a aussi un blog que les développeurs de Unreal régulièrement, comme ce qui parlait, explique, fait un tuto ou explique une nouvelle fonctionnalité dans UE4. Donc, faut pas hésiter à aller voir. On poste ça sur Twitter, donc c'est pas besoin de regarder tous les jours pour savoir ce qui se passe. Donc, il y a pas mal de choses comme ça qu'on fait.
So here's his article, Roland's article, about how to add global shaders to UE4 and code that he gives you, and talks about how to set up the parameters for the global shaders. I don't know if this is exactly what you need, but there's been a lot of questions about creating shaders, and it was enabled and made possible in version 4.17. So, is that it? Hey, thank you. Merry Christmas.
Question?
Is there some kind of certification for Unreal Engine?
There is no certification. There probably won't be, because we kind of think it's bullshit. It's kind of something that people sell to people so that they can go in someplace and tell them that they have something that doesn't mean much, right? It's a way of making money as opposed to a way of really qualifying a skill set. Well, let me explain it this way. Epic has about 500 people of them, and if we issued a test at Epic, maybe 10% of them would pass the test. And these are people that make games. And the reason is because Epic is a very wide tool set, and most skills required to use it are very deep, right? So in order for us to generate any kind of really qualified certification, we'd have to actually make hundreds of them. And in order for us to do that, we'd have to be interested in making a lot of money out of them, and we're not. So there's nothing in it for us, right? So we'll let somebody else worry about that, because we don't need to make money off of people for them to have certifications. Now, having said that, I've been to China, and I've been to South America, and I've been to countries where certifications are really important for business, and I tell them, make your own and send it to me, and if it's good, I'll put a stamp on it. But it's nothing in it for Epic, because we're not interested in making money from education. We're interested, but we just don't want to.
Other questions? Yes.
Hi, this could seem like a weird question, since UE4 is a powerful 3D rendering tool, but does it provide 2D rendering tools? And some some tools to use to mix 3D and 2D or 2.5D, some things like that?
Yes. So it has the capabilities to. We have a tool inside of Unreal Engine called Paper 2D. That have you looked at it? So there's a tool called Paper 2D, and Paper 2D is a full flipbook sprite-based editor. Excuse me. That people use to animate a 2D type of a workflow. So it's got a full sprite-based editor. You can animate things like you would and render it, and it has a very fast 2D render. That's one type of two-dimensional render. The other one is Unreal Motion Graphics, which is a very powerful interface for rendering user interfaces, but people have also used that for animating 2D cards and things like that. Now, having said that, it is not something that we have a tremendous amount of interest in, generating two-dimensional renders inside of Unreal Engine as a sole purpose. Yes, our main focus is rendering 3 dimensions. So we do not invest a lot of programming resources in the two-dimensional side of Unreal Engine. And the way that I say it to some people is it's, sometimes you don't want to hammer a nail with a chainsaw, right? So sometimes you have to pick a tool. And even from a mobile capacity, the mobile that we focus on intently is mobile 3D, but not particularly mobile 2D. That's not to say that we don't have tools that are capable of it, but there's not a lot of current engineering going into Paper 2D. There is engineering going into Unreal Motion Graphics because we need Unreal Motion Graphics to drive Paragon and Fortnite, but there isn't a lot of games that we are doing internally that are using Paper 2D now. There are people that are developing entire 2D engines that sit inside of Unreal Engine and selling them in our marketplace. And there are some really powerful two-dimensional images that are sold by third-party contributors in our marketplace, right? So you can go to our marketplace here, and because all the source code is available, there are people generating separate renders, and I'm familiar with at least one very powerful two-dimensional rendering engine that you can purchase that is much better than Paper 2D. And that's because we don't need it internal to Epic. So I hope that answers your question. It's not that we don't care about it. It's just that there's no precedent internal to Epic why we need to make it better because we don't use it. And that's what drives a lot of these features. The replay system is there because Paragon needs a replay system. Networking multiplayer is there because all of our games need that. Landscape is there because Paragon and Fortnite need landscape. AI is there because our games need it. A lot of these features are there because the games we make internal require the best one, and we make it for ourselves, and then our licensees also benefit from it as well. 2D is not something that we spend a lot of time with.
D'autres questions?
I never use Unreal, and that's why I'm here today. But what do you think about Unity? Unity?
About Unity?
Yeah.
But I think it's a great tool. I think that it's a good place to start learning. Also, I think that Unreal is in America. We have these enormous hardware stores, right? These stores where you can go in to fix a small problem in your house, and then you can't even find the thing you're looking for because you just want to fix the latch on your cupboard that doesn't allow it to close, right? It's just this one little piece that costs €1, but you go into the store and it has everything and you can't find that one latch, right? So sometimes I think that people want to do a simple thing and they come into Unreal and every tool to make Grand Theft Auto is available to you there, and it can be a little intimidating. However, that doesn't stop you from going into the store and saying, where is the damn thing that I need to buy for €1 to fix my thing? And you get it done, right? But the reality is that you can go in there and do anything from a small thing to make Grand Theft Auto in Unreal Engine. The reality is that you just have to find your way to the thing. And so we spend a lot of time on this. And what I can tell you all is something that very few people know. This learning resource site is completely being redone. And in the next November, you're going to have a brand new documentation site that is going to be state-of-the-art documentation site. And then
Better UX.
a much, much better UX. Celia and her team has tested it extensively already and given us a lot of feedback on it. And then about 3 to 6 months later, there's going to be a full learning portal. So if you're brand new to the engine and you want to go watch videos and then have exercises and then even have a self-test to see if you've learned something and terminology sheets, that's all coming. It's coming in many reasons because the enterprise business is demanding it of us, right? If you're an engineer at Audi and you need to learn it, you don't have time not to learn. You don't have time to wander the aisles looking for that latch, right? So we have to make it. And Unity's not different, okay? What happens and what I've personally observed, and as a professor, I've spent years teaching Unity as well. What I've taught my students is to go and find the answer on Google and not learn it, just copy it into your project, right? So some people learn it, some people just copy it. That's not especially learning it. That's just asking somebody else to solve it for you. So I think there are easier solutions you can find in other tools. And I'm not saying that's what everyone does. I'm just saying that it's easier to do that sometimes with some other workflows. And so I think it's a fantastic tool. I think Construct is a great tool. I think Game Maker is a great tool. I think that it's fantastic to work your way to something that solves the right problem, right? And what I instituted when I was a professor and what I've seen other schools institute is they have a natural progression from Construct to Game Maker to Unity to Unreal. And what I've also noticed is that by the time a lot of students get to their capstone work, their finished graduation projects, many of them start choosing Unreal because this is a very professional tool set. And what I know from experience is that no one hires students, right? And if your work, when you graduate from school, looks like a student, you have a problem. You have to look like a professional when you graduate because my experience is that no one hires students. And so it's easier, in my opinion, to look like a professional in a professional tool. And I'm not saying that Unity is not a professional tool. I'm just saying that everything is here to allow you to demonstrate anything you choose. So I don't know if that's a good answer, but that is my answer and I'm sticking to it.
So if no one has more questions, what I propose, and you'll tell me if that's relevant for you, Louis can open a project and show you a little bit of blueprints. Would that be interesting for you? Yep. All right. And we're gonna stop around 7, and then we're gonna have drinks, and we can talk some more at that moment in a more casual way. All right, Louis.
Yeah. Okay. So I think one of the things that some people have apprehension about is how to use blueprints and make things work with blueprints in Unreal Engine. Let me see what I have open here. Okay. So I made this the other night in the hotel room because it shows a variety of different ranges of things that you can do with Blueprint. And it's not about making something pretty. It's just about showing you the functionality of programming. If you'd prefer to see something made pretty, I can do that easily too. Would you rather see coding or, blueprint coding or making something look good? Coding, yes? Okay. So what we have here is, let me push play and you can see. What I've created is basically a drone that you can fly around. And this actually takes advantage of a lot of different systems, which is the controlling of a character. and the control mechanics of a character. And he also shoots. And then also, one of the things that I really like about, we waste a lot of energy in the US. In France, every time you walk by a light, it shuts off automatically and it turns on automatically. So one of the easiest things to show you about blueprints is how to create this really base interaction, right? And that's one of the most powerful things, is that if you are an artist or a designer who has no idea how to do something that's programming based, these are really easy things. So let's talk about some of these things and how they come about. Unreal Engine has a very powerful framework that's built into it that in a number of other engines you have to create from scratch. But Unreal Engine, because we've been making games for so long, there's a lot of things that are built into it that you automatically have access to. So I'm going to build this project basically from scratch so that you have a sense of how it comes together, and we'll get as far as we can until they kick us out. Plan? So I'm going to launch. This is the window where I have all my versions of the engine. You can download Unreal Engine all the way back to 4.0. The current version is 4.17. So when I launch the engine, it's going to bring up a choice menu of what I want to do next. And I can build a new project, and I can build it based on blueprints or C++. And it doesn't matter. You don't have to make a choice. If you decide to make a blueprint project, you can turn it into C++, or you can have both at the same time. This is just your initial choices that you're making as you're loading a project. So we'll make an initial project. You have a series of templates that are available to you. And these top templates are just head starts, right? So I can make a first-person type game that'll give you some arms and a weapon to shoot and a small environment to immediately test in, a flying game, a puzzle game, rolling, scrolling. There's even a virtual reality template that will give you hands that you can go and reach and pick things up with, and the ability to immediately teleport through an environment. There's vehicle games that give you physics and vehicle springs and shocks and friction and braking. There's a top-down sort of a flying game. There's an isometric game where you click around and move your character in an isometric style, third-person, 2D side-scrollers. So we don't ignore it completely, even though most of this is 3D anyway. And then an advanced vehicle with more sensitive springs. You don't have to pick any of these. You can pick them after the fact, right? So you can start with a blank template and bring any of these in. And basically what's valuable if you're brand new to the engine is just to go through each one of these, because they all are manipulating the framework of the engine a little different. And there's a lot to learn from each one of these. If you choose the C++, you'll see that most of those templates exist, and you can actually see how the code is generated for the C++ side. The only one that we didn't make is the VR one, and that's because Tom Lumen, the guy that made our VR template, went off to make indie games after he generated this template for us. But he's a great guy, and he's doing a lot of cool stuff for us still. I'm going to make a blank one. I'm going to choose desktop, console, maximum settings. These are basically just quality settings that you can turn on or off. Once again, these are all editable after the fact, but maximum quality just sets all the variables for the rendering engine to make sure that you have glows and that you have basically depth of field and ambient occlusion and all these things that make your scene instantly pretty. Those things come at a cost, right? And if you're making a mobile game, you may not want them to cost you something from from moment one. So you can turn those settings down. You can turn them down after the fact easily. And then you've got the ability to load starter content, which is geometry, some particle effects, some audio effects, some built-in blueprints that allow you to do time of day already automatically. The thing to keep in mind if your target is a mobile game is that if you load starter content, it's about 100 megs worth of content. So if your target executable file is under 100 megs, if you want to make a 25 meg executable and you load starter content, you're going to have to get rid of that stuff at some point because you've got a lot of junk you put into your project from moment one. So let's make a project, and we will call it My Project 05, because I don't know how many I made. And we'll create it. And what's doing right now is just creating a series of folders. If I'd chosen the C++ template or side of things, it would be creating my .h file and .cpp file and preparing me to launch Visual Studio. If you're working in the C++ side, it does work with Visual Studio, and it you don't have to buy Visual Studio. You can use Visual Studio Community. So if you decide, I'm going to click on this little button here, which takes my content panel here, my content browser, and just gives me the folder view. This is the way it used to pop up, and I'm used to it, so I like to see it. Now that I've created a blank project, this is just the load screen. Not the load screen, but the load menu. It's better than seeing nothing and something blank, and it just basically comes in with a lot of base content so you can see something when you start. It already, believe it or not, has some blueprints loaded. You can tell something is a blueprint because here in the World Outliner, it's got blue text. And you can instantly access it by just clicking it. So that's going to open up the blueprint editor. And here comes my blueprint window. And what this is the skybox. You see that sky up there? That is actually a mesh, but that mesh is not just a mesh that I dragged into the world. It actually is a blueprint. And that blueprint actually holds an actor, a component type, which is the sky. But the reason that it is what it is because I can select it. And if I go down here in my details panel, you see that I've got many parameters. Right now it's hooked up to link to the light source. So if I select that blueprint and I go and find it, let's find something else here. And I start to rotate it. Well, let me decouple it from the light source. It makes it much easier to manipulate. I'm just going to clear this. And now what I can do is actually change the sun height. So there's the sun. Oh, hello, sun. And as the sun sets and I look up, I'll see stars up there. And actually change the brightness of the stars. I can change the opacity of the clouds and make the clouds move faster. Now, the reason that all works is because I'm manipulating public variables in a blueprint. And I can look at that by looking at the blueprint, right? So if I drag this up here and nest this blueprint editor so that we can all see it clearly, and I look down here in the variable stack, what I see is everything that I just manipulated. Star brightness, cloud opacity, cloud speed. And because I can see the little eyeball, that means that they're public variables. And when they're public variables, they get exposed when I select the blueprint in my details panel. And as I'm manipulating these variables, really what I'm changing is this blueprint code here. Sun height. Sun height, sun height, sun height. And what's all these variables are doing is just changing, in this case, float values that are driving materials, right? They're driving materials through just math nodes that change the vector parameter values. It's basically just a color. It's changing the color value of cloud color and zenith color and horizon fall off. And it's giving it just some numbers. As I put in this number, make it an absolute value, and make it the alpha value and slide it between a range of 3 and a range of 7. That's all that's saying. And then apply that to this color. Now, I've got 3 tabs up here. This one's a function, so I've got a construction script and a viewport. The viewport is where the mesh is. Up here is where I add components to a blueprint. The only component that's currently added to this blueprint is a static mesh component. It's the mesh itself. And there it is. It says, give me a big old sphere and put it there. And then the construction script drives all this information in the viewport. If this was a runtime function, in other words, if I needed this script to run when I pushed play, I would need another window, which is the event graph, which would pop up right here. So now that you've gotten just a very brief overview, let's just make some of this stuff from scratch. Let's start. How about all right, so let's bring in, I told you we can bring in other templates. If I go to this new here and say add features and content packs, you see that I can quickly add any of those other content packs that you saw earlier. So let's bring in the top down because it gives us these columns that we can play with. Sure, let's do it. And what I can do is just say add to project. And you see what it did is it brought in this folder called top down blueprint. And it also gave me a map here. And if I want to load that map, all I have to do is double click it. No, I don't want to save the one I just messed up, and it gives me this map here. So that's good. It got me where I showed you a minute ago. Now this map is set up so that I immediately can go in and do the top down, and it gave me this character. And this character, what is he? Because he has this blue thing. What does that mean he is? Huh? That's right, he's a blueprint. I can click on that and it shows me the blueprint for the top-down character. And this is just basic navigation for that character. I don't really want him there because when I push play, if that game mode is enabled, he's just going to run around, and only him, because that blueprint is in the world. What I want is to delete him and instead use a player start. Okay, so this is my tool panel over here. The player start, as I drag it into the world, will say that any pawn that the game mode dictates should be driven will spawn here. So you're like, well, what the hell is a game mode? Okay, let me show you what that is. Here is in the settings, there's a little window called world settings. And in the world settings, this is a lot of really important, just general information about your level, okay? Like, how far do I have to fall before I die? The kill Z is negative 1,000. And underneath is the game mode information as well. So right now, the game mode override, the one that is going to launch when I push play, is the top-down game mode. And if I open it up, I can see that that means that it has some rules. The rule is that the top-down character is the default pawn. That means that when I push play, he's the one that I'm going to possess and become that guy or girl or whatever. It says the controller of that pawn, the control mechanic for that pawn, is this mechanic, top-down controller. And then there are other things that can come into play. This is a really powerful and important part of the engine because you don't have to write this yourself. And this is true for a VR project that's not a game. If I am making a configurator for a car and you want to hand it to a client and you want to push play and make it interactive, the minute you push play, you are the audience, or you are the buyer. That's who the game mode says. Who's the pawn? The pawn is the buyer. What controls him? Well, the motion controllers control him. And what is the objective? You know, what is the game state? The game state is to have him move to the car and get in the car and interact with the car. What happens if he does this? That's the player state, right? And then there's, you know, if he gets out, there's options to provide a HUD and spectator mode, and you can enhance and augment these. As a matter of fact, you can have multiple game modes inside of a map. I can walk up, get inside of a car, and then push on the HUD of the car, you know, a game screen, and then all of a sudden be in a mini game, maybe a puzzle, which is a completely different game type, right? I can completely switch game mode. This is a very empowering system in the engine. But the only reason I bring it up is because what I want to do is just create a new one, right? Because if I push play here, now I'm playing that mode that I brought in just a second ago. And that's not really very helpful. Let's use it really quickly and make our first blueprint without changing anything. Let's make a quick blueprint that just does that light toggle. So you see instant satisfaction of it. So I'm going to create a folder in the content, new folder, and I'm going to call it blueprints. And I'm going to enter into that folder, and I'm going to right click and create my first blueprint. So blueprint class. Now it brings me into this little help wizard that says, well, what kind of blueprint do you want to create? And this is where you get your first look at really the architecture of Unreal Engine and why it's a C++ engine. It is fully object oriented. And yes, these are shortcuts, but if you really open up this menu here, what you see is the architecture of Unreal Engine. The core base structure of Unreal Engine is this notion of object. Object is the building block of anything in the engine. It's the top inheritance node. Actor is anything that can be put into a level. Every one of these things back here is an actor of some kind. A light is an actor. A static mesh object is an actor. A skeletal mesh object is an actor. A reflection sphere is an actor. A blueprint is an actor that you put in the scene. Particle systems are actors. Everything's an actor. There's many different kinds of actors. All of these are actors that you can create as blueprints. One of the really important ones is pawn, right? I can roll down here and find pawn as an actor. And you will notice that underneath pawn is character, right? Because a vehicle can be a pawn. I can be walking along and all of a sudden open the door and get in a car, and my consciousness transfers to the vehicle, and now I'm driving the vehicle. That's how you do it in a game like this, is you transfer your pawn from a walking bipedal character to a driving character. And that's just a pawn swap. So you go up the hierarchy and over and down to from character to wheeled vehicle, or from character to drone, right? So you can create any kind of pawn you want. These are just some fast ones that already have components in them. If I go into character, character already has components that make them easy. And many of these pawns already have things because we already know that we're going to do things with them. So this is an important thing to just know about. I'm going to start with a base actor class blueprint because it gives me everything underneath, right? Everything under here, everything above here is available to me when I make an actor class blueprint. I'm going to call this BP _ light. And I double click it and it brings me to that blueprint editor like you saw before. I'm going to nest it up top so you can all see it very clearly. And there's my 3 viewports, the viewport where I add components, the construction script. Once again, the construction script is anything that happens in the level editor. The event graph are things that occur when I push play. Any coding that I do that I want to occur at runtime. The construction script are things that I manipulate as tools, or things like that in the editor. So let's start building functionality. The first thing I want to bring in is, if I look here, I got this white thing. That's going to cover up my light. I want to get rid of it. It's just a visual element. It won't render in the scene. It still irritates me. Let's get rid of it. I'm going to use a scene component, which is just a transform, right? A scene transform, it just has the ability to grab it and move it around. We call this in Maya or Max just an empty node, a transform node. I'm going to grab it and drag it into my scene default, and it replaces it and gets rid of that white thing. You can use collision boxes or other things to do that. That's just a habit that I have that I like. And now I will bring in a static mesh. Now, a static mesh is in there, and if I look over here in the details panel, you'll notice that it just doesn't have a reference for anything. It's an empty static mesh. If I click on it, it gives me all these different things that I can bring into it. I can bring in a chair if I want there. Well, I don't want a chair. What I want is this little sconce thing. I forget what it's called. Let's see if it's called lamp wall. Yep, that's what it's called. So it brings in this little lamp that I can put on the wall. And it's going to need a light, so let's add a light. And it says, well, here are all your light choices. How about a spotlight? And I say, yes, I'd like a spotlight. And I'm going to drag that spotlight. Now, you see how chunky that moving is? If I want it to move more smoothly, I can just change the snapping. And I hit the WER keys to manipulate my assets, so I can move that into position. The way I want. And now I have all the properties for the light here. I can actually change the cone angle. I can change the radius and the fall off of it, which you won't be able to see. You see that the intensity is set to 5,000. You're like, why would I need so much? And the reason you need so much is because it currently has inverse square turned on, which inverse square is a property of light, which means that it drops off in intensity as it falls off over distance. It actually is a proper way to do illumination in CG and a proper physical property of light, but it also is a mathematical calculation that if you don't need it, don't use it. If you turn it off, you actually can dial that back down to a more human number like 20 and save yourself some math calculations that are not necessary. And you can change the color, so let's make it a little bit more interesting, whatever you can choose. Okay, so the other thing I want to do is, we'll leave it like that for now. Okay, so let's give it a trigger volume. I'm going to select the scene so it doesn't get parented underneath and say, give me a box collision. And you see that it creates a very small little box collision. Well, I want my box collision to be much bigger, so I'm going to make it maybe 200 by 200 by 200. And this is the box extent and shape there. You can scale it here, which is just an extent, which is another way to scale it. You can use these scales as well. And I'll grab the static mesh sconce that has the light as its child and drag it to the edge so that I can easily sort of view it. I can go to the right or left here and see where it's going. There's a little faint version of it there. And that should be good. Now, let's grab that collision box and start writing some code to it. What I want it to do is first be aware of its collision properties. I want it mostly to be aware of me, right? So let's have it interact primarily, overlap with the pawn, because I'm the pawn, right? When I push play, I become the pawn. So I'm going to say, let's just have you worry about the pawn and nothing else, just in case I'm doing something else. I don't want to accidentally shoot a light on, right? I want to cross it and have it turn on because my pawn crosses into it. And then let's create some functionality for it. I have a bunch of shortcuts here at the bottom, some events that can be triggered. One of them is component begin overlap. And they all have little hints. If you hover over them, well, what are these things going to do for me? So component begin overlap calls an event when something overlaps this. You can call this on anything. I can do a component begin overlap on this. I can't do it on a light. It has some different things, you see. If things change here, and these are just basic shortcuts to blueprint elements. Get used to looking for these events. One of the hardest things is that you can do so many things with blueprints is you're like, well, what do you want me to do with them? I can't learn all the things because I don't know what they are. Well, here's a bunch of things you can already do with them. All right. So start looking here. Another place to find them is here. Add event. What can I do with this node? Okay. So let's begin overlap. And the minute I select that node, it pops up over here in the event graph. Remember, the event graph is the one that gets triggered when I push play. And it has a reference to it. It says box. If I rename this thing, it's going to rename it to George. Okay, so now it's named George. Misspelled George, by the way. So what do you want me to do? What do I do when I overlap that box? When my pawn crosses the box, what should I do next? Well, let's grab that light and drag it into the scene. And now I have a reference to that light. And what I'd really like it to do, if I grab that light, is I'd like to change the intensity of it. Can I change the intensity when I cross into the box? Well, let's try. Let's do a set intensity. Ah, voila. I can set the intensity. Now what I need to do is execute this code. So there's an execution pin that occurs. And what would you like me to set the new intensity to? Well, let's actually set it to, 50. And let's go back and set the default light to 0. So it starts off. And when I cross into that, it'll set it to 50. If I want, it doesn't instantly have to do it. I can do a delay of 0.2 seconds, and then it'll set the intensity to 50. All right, cool. That's working out. George, I also want you to, when I leave your box, turn the light off for me. Okay, let's do an end overlap. When I leave the box, let's take the same intensity, and because I'm a bad programmer, I'm going to copy and paste my node, Control C, Control V. I need a reference to that target, which is the static mesh, the spotlight, and I just drag from the node to the node, and I execute intensity, and I say, now set it back to 0. And do I want to do it instantly? No, let's give it a little bit of delay. I could even do some other interesting things. If I wanted to, I can make it have a sound, right? So I can drag out from here and say, how about we play sound at location? Do I have a sound that would be interesting? Maybe, I don't know. Sound, wind. If I had a intentional sound, I could use that. I'm going to cheat and use a sparkle sound. Or a collapse cue. I don't know what that is, but we're going to use it. Well, where do you want it to be? I don't know. Get location. Get the actor's location. Wherever it is, play it from there. Cool, I love it. And then let us copy it and paste it down here. And so that that sound goes away, let's try and destroy the actor. So it should kill the sound afterwards. Let's see how that works. Now, like I said, I just pushed the compile button, the save button up here. You don't particularly have to do that, but that's a really quick, nasty piece of blueprint code. Now I can grab that blueprint down here, since it is an actor, and drag it into the scene. And I can rotate it into place. Let's move it up against one of these walls. Get the sconce where we want it. And push play and see what happens. Where are you? There it is. I heard the sizzle, but maybe it's because, it destroyed the whole mesh. All right, so let's debug it. It could be that it's buried in the wall and the light did not show because it is buried in the wall. Let's pull it out a little bit more. Let's try it again. Where are you? I see the light now. I also am blocking it for some reason. I need to debug that part. Oh, all right, so let's not destroy the actor and debug that part. Let's try and get rid of that destroy actor node. And I set the intensity to 50 and I set it to 0. Light component. Yeah. And check the light. Yes, intensity of 0. It should go up to 50. All right, let's try it again. Let's pull it out there so it doesn't have any issue. There is, I think one of the things is I've turned collision off on this box, so my little actual reticle that's moving around is actually a mesh that I'm not allowing to display on it. So let's fix that by fixing the collision of this box. So let's go back in the blueprint and say overlap. What else could that be? Let's do an overlap all. If I want to reset it, I can just see this little yellow hook, just change it. Overlap all dynamic. So let's try it now. All right, so now I have no issues. I have the audio. Okay, so let's see if the light is actually stuffed into the mesh, and that's why it's not turning on, because it's not turning on. Let's try it again. Not setting intensity still. What are you doing? Use inverse square fall off. Set to 20. Delay. Oh, okay. I set the intensity. Yeah. Light. That should all work just fine. Well, let's debug it. Let's get rid of this for a second and get rid of this for a second and just do a direct component begin overlap. And this is all part of just working, debugging stuff. Now that should set the intensity. This component is the light. Yep, that should work fine. Compile and save. Are you turning on? The audio is playing. Let's pull it forward a little bit more. If you want to change from object to that world mode, you just do it like that. That should be fine. Maybe I've made it too wide. Let's just tune this a little bit. It is activated. You've got to check everything. All right, let's try it again. Is it actually, okay, so it's casting a little bit of light. Is that going to do anything when I change? No, it's off. What am I doing? You see something? No, it's a dynamic light. So it's a movable light, right? So this is lighting mobility. This is a fully movable light. So it shouldn't have anything to do with that because you can see it here. So you just got to debug it. There it is. But when I push, let's do something really quickly. Go like that. We'll make it nice and wide, and we should see it all right there. Yep, there it is. Oh, okay, so it is changing the intensity. Oh. I don't think it was just up against the wall enough. They just weren't seeing it. I need to set the intensity way up. Let's try it again. Let's set the intensity instead of 50 to 300. And we'll hook all the stuff back up again. And push play. It just wasn't showing. All right, so now let's turn it back down so the default is 0. Push play. Now it's set to 0, and I cross it, and it turns on, and it turns off. All right, so it's working as we need it. Now that I've got it in the scene, I can duplicate it, right? So if you want to duplicate an actor in the scene, you hold down the Alt key, and you just drag it over, and it duplicates an instance of it. All right, so I've got 2, and let's grab another one, Alt over 3. So now I can push play, and I've got that one. And this one, I think that one's buried in the wall because you see his lights coming on over there. So we can fix him by pulling him out. All right. So that's a real basic just trigger. So it's 7 o'clock. Do we have to walk out of here, or can we do a little bit more? Are everybody all right? All right. So I'm going to bring in some meshes really quickly. I'm going to bring in I'm going to do an import. And what I have is a static mesh here. And when I bring in, basically I'm working with an FBX pipeline. So this is a static mesh, so I don't toggle skeletal mesh. I've got import. I can turn on import material and texture, and if I actually have appropriately named textures, like I have here, which is drone, it's going to bring in and create a material that already has the existing content. So you see that it created a material and it linked the material to the texture, and it brings in this drone. Already hooked up, basically. And we can talk a lot about what all this means, but let's just get to making the blueprint for it. I'm going to bring in a couple of materials just to make it a little bit more dynamic. The other way that you can get this content in is just dragging and dropping it. So this material is a little flat, so I'm going to bring in a normal map for it and a roughness map for it. So I'll open up the material, and it brings up the material editor, and I undock it from the top, and you see that all that it really imported was the diffuse map attached to the base color. I can drag in the normal map, and I can drag in this roughness map. And this roughness map is kind of special because we optimize things at Epic quite a bit by packing things in red, green, and blue channel. So if I double click the map, what you can see is it looks very odd. And it looks very odd because each channel has different piece of information. So in the red channel, I hold basically a cavity map for the actual asset. And if I look at the green channel, this is my roughness map, where things should be more perturbed or not perturbed. And then if I look at the blue channel, I can see sort of a mask for what looks like possibly the metallic bits. So let's try and hook these up the way that they are here. So what I can do is take each one of those channels and put them in a different place. I'll take the blue channel and drive metal with it. I will take the green channel and drive roughness in a moment. Let me put the red into the ambient occlusion channel down here. And the roughness I want to give a scale to. So what I'm going to do is pass it through a linear interpolate node, which I have a hotkey for with an L. And I'm going to drive the green channel into the alpha. And what I can do now is use this into the roughness and change the values of this to maybe 0.25 and 0.6. And you'll see that the surface there, right in there, has a little bit more shine than areas that doesn't have shine. Let's just go ahead and put the normal straight into the normal channel. And that looks much better. So we'll save that and see what this looks like. And that looks nice. Okay. All right, so we have our asset in there. And now let's make a blueprint with it really quickly to move it around the scene. Actually, what we're going to do is create a pawn. So let's make this as quickly as possible. I'm going to create a new game mode. So I'll click on the plus, and I'll call this, did I already make the game mode? No. I'll call this my game mode. Goes in the blueprint folder. And you see that it already has a game mode here. So then I'm going to create my new pawn class by clicking on the plus, and I'll call this my drone pawn. And it opens up Unreal Engine really quickly. And what I first need is a collision, right? I don't want to use the visual mesh for collision. It's too complex. Asks for too many calculations. So I'm going to use, I can use a box, I can use a sphere, I'm going to use a sphere collision. And I'm actually going to replace the root node with that sphere collision and scale it down to 6. I can fix it later. Bring in a static mesh, which is going to be my drone. So that's called SM_drone. Or is it called RR? There it is. So that brings in my mesh. It needs to be pointing down the x-axis because that's forward. And then the next thing I want to bring in is something that gives it the appropriate movement and the camera to connect it to. One of the things that already has automatic lag is called a spring arm. All right, it's kind of like a selfie stick. So you see there's the spring arm. I'm going to bring the static mesh underneath just by dragging it underneath the spring arm. And if I select it, you see it's just that. I'm going to drive it forward of the spring arm. And I apologize for going fast, but you can see that some of the settings of the spring arm is camera lag and camera lag rotation. And that's going to give it that, just kind of like that, moving with my camera. And now I'll grab the sphere again and bring in a camera. And I can position the camera wherever I want to make it look adequately cool. Super cool. And I'll test this, for how I want it to look in a moment. Now, the other things I want to be sure to do is to move this whole thing back so that my collision is in the center of my drone, right? Do you remember the collision? There's the collision there, and I can now tune that collision to be whatever, adequately big. All right. Okay, so let's make this stuff move. So now I've got a drone. I'm going to save it. If I push play, there it is. Very exciting. All right, thank you very much. See y'all later. No. If I move my mouse, nothing happens. If I push my keyboard, nothing happens. Why? It's got no inputs, right? It's got no control. It's got nothing. It's just a blueprint sitting in space that I told to be the pawn. I need some input. So let's go edit project settings. Let's give him some inputs. Aha, voila, inputs. I've got a couple of different default type inputs, axis mappings and action mappings. Axis mappings are scalar values. Action mappings are press release scalar values as well. I'm going to add a couple of axis mappings. I click on the pluses and it gives me some empty ones. I can have pitch. I can have roll or bank, really. And I can assign them to things. And there's all kinds of built-in controls in the engine already. Game pads, Xbox, motion controllers, Oculus, Steam VR, whatever you want, they're already there. Mouse. Y for pitch. Mouse. X for bank. While I'm here, just to save time, I'm going to make a couple of action mappings. Two of them, one for... I just need one. One for speed up, because I don't think we're going to have time for shoot, but we could if we wanted to. Speed up. And if we had wanted to do it, we could do shoot too, but we're not going to do it. Because here comes Celia. So we can map this to W and find that W right there. I don't need to save it or do anything. I just close it. So I go back to my blueprint and I can go and start building some blueprint code. I can go find that mapping. I can say pitch, and I find my pitch, the one I just made. There's two of them. One's an actual function value and one's an input. So I want the input, and I find bank, and there's bank. These are the ones that I just created. And I want to attach those to the controller. I don't need to create a custom controller. All the stuff is built in. Pitch, I can attach to pitch in the controller. P-I-T-C-H. Would you like to add this to the controller pitch input? Yes, of course. Voila. Would you like to attach bank to yaw? Yes, I would. Right? Because I have pitch, roll, and yaw. And if I want to move forward with my drone, I can just use event tick, which is a constant ticking pulse, which you need to use very sparingly to add input. Add input. Where is my add? Not add input. Movement input. And the last thing I need as a component is a float. So because we are used to doing things that float and move, we have a float pawn movement, which already has built-in maximum speed. I'm going to set this down to like 350. And I'm going to connect that to the world direction. So I can get my controller, right? Because remember, the framework already defines a controller, the default controller. So this is the default controller that's driving my character. I can find out where forward is, find the forward vector, right? So I'm just asking Unreal to do what it already knows. The framework defines a controller, tell me where forward is, and attach forward to the world direction. Whoa, that's a lot of speed. Let's calm down, everybody. Calm down. Oh, that's because it's still set to 1200. Let's do 300 up here. Turn numlock off. All right, cool. I think let's set it to 0 real quick because I've got pitch and yaw reversed. Okay, let's see. I forgot to do something. You need to go up to your class defaults and you need to tell your controller to control pitch, yaw, and roll. And now I'll have control of pitch, yaw, and roll. And now if I go back and turn on some forward impulse, I can fly around and turn the lights on. And now it's just a matter of starting to tune everything, right? I can already tell that I'm backwards on my input. Are we done, Celia? Are you here to tell me that I have to stop? Clearly, I can do this for a lot longer.
I know. That's why I'm coming over here. I don't know about you guys, but I'd like to have a beer. But that's just me. It's not that I'm not interested. I love that stuff, but I love beer too. So maybe if there's maybe like short questions for Louis about that. I hope, was it useful? C'était utile un peu de voir.
So here's what it looks like when it's done, by the way. You can bank. You can speed up based on a ramp curve. You can shoot by spawning a projectile. You can pitch. And it's just basically all I did to this is add a couple of more nodes that do nothing more than multiply, clamp the multiplication so that it doesn't go past 90, interpolate the math so that it smooths it out a little bit, and connect it to the roll vector, and then tell the thing to roll, right? And then the speed is nothing more than an animation curve, and say go from this value to that value over time as I press the W key. And use that to drive the max speed of this node here. And so Blueprints is just finding values and setting values with math, which is programming, right? Sort of. There's more to it than that. I know I'm making light of it. Yeah, any questions?
Merci Louis, déjà. Je ne sais pas si vous voyez... Ah oui, la photo. Avant la photo, je ne sais pas si vous voyez l'icône qui pulse là-haut. C'est les tutos. Donc, si jamais vous avez il y a pas mal de tutos là-dedans. On a des heures et des heures de vidéos sur YouTube, sur la chaîne Unreal Engine avec plein de tutos. Il y a un livre en français. Can you pull out the French book?
Yes. This presentation has a lot of the learning resources for the engine. And I usually put these presentations on SlideShare. If you're familiar with SlideShare, it's a LinkedIn product. And if you go to Learn Unreal, there's a bunch of presentations that have all the learning resources. This is a book in French on Unreal Engine by a gentleman that has been writing these books. He's got 4 of them now, and they're pretty good.
Ouais, donc on va faire la photo et après on va boire de la bière ou ce que vous voulez.
There are lots of books in the engine. So if you're interested in AI, there's books on AI, there's books on lighting and rendering, and there's lots of free resources. So I recommend you download this from Learn Unreal, from SlideShare. There's blueprint things, there's networking things, there's a fantastic UE4 style guide on GitHub about how to teach students or how to learn how to properly name things and set up C++ projects, and fantastic resources on VR and C++. Really great stuff. So, and then there's some really fabulous courses on Udemy that we review and in many cases approve for public consumption. And we, find these guys. This guy, Mohammed Mohim, is an Egyptian developer who has a fantastic website. Chris Murphy's an Australian developer who has a really great course on Udemy. And there's a lot of really fantastic stuff on Facebook. There are these user groups. There's UE4 Game Development Club, UE4 Devs, Educational Community, and UE4 Help Desk. So there's a lot of people on Facebook that are just answering questions and providing us a lot of really helpful services. Yeah, let's take a selfie. Would you guys take a selfie? Come on, join. You ready? Say 1, 2, 3, and everybody go, yeah! Ready? 1, 2, 3. Yeah. Again, 1, 2, 3. Awesome. One more. Just to make sure you all make a funny face. Thank you.